All right, everybody. This week I'm going to show you how to complete assignment 4, and I'm going to walk you through kind of some of the stuff you have to do to get configured in order to be able to do this assignment, and then I'm going to show you how to do the tasks that will ultimately result in you producing the screenshot that I've got out there on Blackboard. If we take a look at assignment 4 on Blackboard, we can see that I've got this ojdbc7.jar file here, which is what you're going to use to allow R to connect to our database. Then I've got the assignment 4 screenshot PNG, shows you what your deliverable will be for the assignment. And then I've got an assignment 4 R script that you can download and open in RStudio that will give you all the kind of stuff you need for connecting to the database and whatnot, and give you a starting point for some of the things you're going to see me do in the video, and then it'll be up to you to kind of create the rest of the variables that we'll see that we create in this video. So if for some reason you don't have a Java runtime environment already on your machine, you can go out to Oracle, and I've put this link in the R script file that I've given you guys. You can go out to Oracle and download the runtime environment that you'll need to use in order to connect to the database with RStudio. Obviously, pick the flavor of operating system that is relevant to you. Don't worry too much if this, if this particular version is different. As long as you're in this 8 range, you'll be fine. Download that and do what you need to do if you don't already have Java installed. But I would assume that just about everybody on the planet has Java by default. If you don't, then just go ahead and use the installer and you'll have it. All right, so I'm going to minimize Blackboard there, and here you can see that I've got RStudio up, and in assignment 3 you guys will work through kind of the basics, so I'm going to assume by the time you get to this that you already kind of know what you're doing. I'm going to show you how we connect to everything here, but first we'll just kind of go through the basics. One, set your my computer variable. We always use this in our screenshots. Just kind of proves that you're not just copy pasting the screenshots that I give you. Next thing you're going to do is you're going to set your working directory. You can see that this is going to be relevant to your local machine. So I've got mine set to the directory I've got set up where I keep my R scripts and other stuff I'm going to use. You'll need to set this to the working directory that makes sense for you on your machine. So I'm going to set my working directory. Next, I'm just going to check and see that there is a environment variable already set on my machine for the Java home. So this is very important when we install the our Java package. Presumably we're all going to be on 64-bit machines here, so you're going to want to make sure that you have a 64-bit JRE installed on your machine, and your Java home variable points to that directory. Now, if you don't have a Java home environment variable set up, you can actually use this command here to set that variable. But I'm assuming, again, if you've installed a Java runtime environment, that there's probably a Java home variable set on your machine as well. And if you have any problems with this, the internet is pretty helpful with that sort of thing for your particular machine, or I'd be happy to help you figure out how to get this set up on your local machine. So My Java home is set up correctly, and so I know that this should work fine. So the next two things you're going to want to do is you're going to want to install these two packages. One is rjdbc and the other one is rjava. So to install these packages, I'm just going to highlight install packages here, click run, and then you should see that it will go out and fetch these packages from the CRAN repository and load them up into your machine. So if you run into, the next thing you need to do is load the libraries in so that we can use them. So same thing, I'm just going to load these two libraries, and if everything is okay with Java on your local machine, then it should load right up without too much of an issue. And then we can run these two sort of check functions here to see if everything is the way we expect it to be from a Java perspective on our machine. You can see right here that R is telling me that this is the version of Java that we are using. So once we've got our rjava packages and our rjdbc packages installed, we are ready to actually connect to our database. So I'm going to go ahead and show you how to do that. The way that we're going to do that is we're using a bunch of variables that we'll use for our connection. So the first one here is this driver class, and you can leave this just the way it is, and if we run that, that just puts that value into our variable. The next thing we have is the path to our OJDBC 7.jar file that I attached to the assignment. So I happen to have mine placed in this particular directory. Yours will obviously be somewhere else. One thing to know about file paths on this for Windows, and I'm not quite sure how Mac handles it here, you have two options. You can either use forward slashes in your file path, which is more of kind of a Linux convention, or if you're used to the way that Windows handles file paths, you just need to double up the slashes in between the directories as you're going through here. So you can see I've got them set up either way. Here I'm just using the forward slash syntax because it's just easier to deal with in my mind. So I'm going to go ahead and set that driver path variable. And then the next thing you'll need to do is set your connect string. And so I'm not going to show you the connect string that I'm using here because we put our stuff out on YouTube, but in the file I include with the Blackboard assignment, you'll see that this one, you have this value and you can just set that here. So I'll set that variable. You can see the connect string, and then the next thing to set would be the username and password. So if I were to set both of these here, obviously you're going to put your username and your password, which will be exactly the same as you used for SQL Developer in assignment 2. So if you've forgotten it, just go out and right click on your connection and select properties, and you should see your username and hopefully remember your password. So now that we've gotten there, the other thing we're going to do is we're going to use a variable that has a SQL query into it that will just help us confirm that we've been able to connect to our database. So I'm going to go ahead and set that, and this just makes it easier. We could put all this in as text to our driver and connection and query that we submit, but it's easier in my mind if we use variables to do this because it just makes this less messy. So I'm gonna go ahead and set my connection credentials right here, and I'm just gonna hit another file where I've got the things to set those. For you guys, you will have the correct connect string here that's in the attached file on Blackboard, and you will have changed your username and password to the right username and password that is relevant to you. So I'm going to go ahead and set mine right now. And you can see right here, oh, hey, it's mad at me because I hadn't set my working directory up here. So I'm just going to make sure I reset my working directory here and get my other two variables in. You guys won't need to run this particular piece of code. This is just so I can set my connection parameters whilst not showing them on screen here. So if you've got everything set up correctly, you should be able to instantiate a JDBC driver. So I'm going to go ahead and execute this. And now I should be able to actually make a connection to my database. So I'm going to highlight this line, go ahead and run that. And if everything has gone correctly, here we can actually submit a query to our database, and I'll go ahead and run that. And you can see I didn't get any errors, so presumably it's right. And if we print out the instance name variable that we used, you can see that I've actually got the results of my query. So this DB host is the internal IP address for the database server. You can see that I'm using my test user that I've used for everything else here, and we can see our service name and the fact that we're using JDBC thin client to connect to the database. So, all right, if we've gotten this far, now we can actually do some stuff on our database. You'll see I've got commented out here this disconnect statement. If I wanted to, I could disconnect from the database by executing that. You can say it returns a true to say it's been disconnected. And then if I wanted to reconnect, because I've already set up my driver, the only thing, and all the username and password stuff that I need, the only thing I need to do to reconnect to my database is run this JDBC connection one more time. And actually, I don't think I even need to do that. We may be able to just run our query. Oh, I was wrong about that. I need to run that connection first. So if I rerun the JDBC connection, this gets us a connection to our database. Then we can resubmit our query, and then we can see one more time if we print out the result, it looks exactly the same as it did before. So now that I've been able to connect to the database, I actually want to do some stuff with it. So we're going to just try creating a table and inserting some data on our database from our RStudio client here. So I'm going to go ahead and just clear our screen off, Control L. And then I'm going to go ahead and get the iris data set, which comes with your R installation. I'm going to create a copy of it called iris rename here. And then we're going to look at the column names that come out of that data set. So if we pull this up, we can see that the column names are sepal.length and all these, I don't know if that's correct pronunciation of that, but you can see petal.length is petal.width, and have a period in between the two words, and that will not work on an Oracle database, which is what we're going to push this data into. So we're going to need to replace those periods with an underscore character. We'd have to delete them out there. So there's actually a function that we can use to do that, and you can see if I highlighted this right here, we would see, we should see what this function will do. So you can see there that by running this function, it replaces the dots with underscores. So in order to actually make that change on our iris rename data set that we have here, we have to use this colnames function, and we have to pump those column names in by using that gsub function that we have. And this is included in the file that I gave you guys, so you don't need to bother yourselves with writing this. You can just execute it. I'm going to go ahead and execute that, and then if we recheck our column names on our iris rename, we can see that we've got our column names now changed to something that the database will actually accept. So now what I want to do is actually write this to the database. I happen to know that I've already created this table. So if we come out here to SQL Developer and we take a look at our tables, and my connection disconnected. You guys are probably pretty familiar with that right now. So I'm just going to click disconnect, reconnect here. Now that we have our connection reestablished, we can see the iris table that we created is out here already. So what I want to do is I actually want to delete this table so I can show you guys what I'm up to. So I'm just going to right click it. We can see under table operations I have the ability to drop, and we'll just go ahead and drop that table. It'll be gone, and now we can come back out here and see if we can get connected. So let's see, I've gone through and created the data iris set here, or we've created our renamed data iris set, and you can see that I've got the renamed columns that will work for our database. And now I want to actually write this table to the database. So I'm going to give the table out there a name of iris rename tab, and we're going to use our iris rename data set that we have here locally in R to create this table. So I'm going to go ahead and execute that, and we should see that all is well in just a second. And then if we wanted to check on that, we'll be able to actually run a connection, run a query against it. All right, and now we see, after giving this a second, it went ahead and created the table on the database. And if we wanted to, we ought to be able to run queries against that database to prove it. So I've just got a little select statement here to count the rows from the table on our database. Using the database connection we should already have open. So if I go ahead and just run that, we'll see that it says there's 150 rows in the table that we created. Now, if I'd like to read this data into a variable from the database, I'm going to run this command to read table. I'm giving it the name of iris rename tab, and I'm pushing it into a variable called D. Now that we've done that, we can go ahead and disconnect from the database just to sort of prove there's nothing up our sleeves. We'll check the type of data structure we created here. We can see that it pushed all that into a data frame, and if we want to actually check the values that we have here, we see that just using the head command for the first 6 rows, we see that we have pulled this data down from the database table that we created. So that's all well and good, right? We were working with some Twitter data that we had put on our database. And so what we're going to do is we're actually going to go ahead and try re-executing some of the commands that we used as a part of assignment 2. So I'm going to go ahead here. You can see that, and I've given you guys these things. See, I've got a bunch of variables I'm using to hold the various SQL statements that we're going to execute here, and you should recognize these from assignment 2. So I'm going to go ahead and just execute all of these to populate those variables with the select statements. And we'll see that should be successful. And now I'm going to come down here, and I'm actually going to reconnect to my database, and all of these variables here should already be set, so we just need to get another active connection to our database. I'm going to click that, and it came back without error, so we should be in good shape. And now I'm actually going to, using the variables that are holding our SQL statements, I'm going to execute a query using the connection that we just established with our database and push this into a variable. So if I do that, just execute this first one here. You can see it's going out to the database, executing the query that I've created, and then it pushes that into a variable. If we look at the class of that variable, we can see again we've created a data frame, and if we were to run the head command on that data frame, you'd see that we've got a bunch of Twitter data that we brought back. So all right, I'm going to go ahead and just execute the rest of these SQL statements, pushing those into their own data frames. You can see that went pretty quickly, and then if we wanted to double check that we actually had values in all of these, I can just run that head command on all of those, and you can see that indeed we do have data in our data frames, which are the result of SQL queries that we've executed against our database. So this is functionality that's you know, pretty important, because in a lot of cases you are going to at some point or another want to get some data out of a database. So getting comfortable with how to interact with the database, push data back and forth, because maybe you're doing stuff in R that you would like to persist to a later date. Using a database can be a great way to do that. So getting comfortable with how to connect to it and move data back and forth is definitely important. The other thing that I wanted to show you about SQL, and you guys may recall that I've told you that I believe SQL is one of the most important languages you can use if you're going to be doing data mining or any type of data analysis. There's actually a package out there called sqldf that allows you to use SQL syntax against the objects such as data frames inside of your inside of R, right? So instead of writing SQL against a database, I can write SQL against a data frame, which is an object that exists inside of R here, right? And so if you come from a database background, you're comfortable with writing SQL already, then something like sqldf will be something that's pretty comfortable for you. So you can see again, we're just installing the package, and then we load the library up so that we can use it. And if nothing's wrong, we should be able to do that. So I'm going to go ahead and just check the column names on my v2q variable that we created. I'm also going to check the column names on this TP-UPD. And we can see, we can grab those column names, we can actually use them in our select statements. So here I'm just going to do, we've got this data frame out here called BTQ, and I'm going to issue a SQL statement against it where I fetch the usernames and the number of tweets that they've done, and I only want to return the usernames having a greater than 10 tweets coming out of our data frame. And you can see I'm taking this and I want to push this into a variable here. But if we just highlight the sqldf part of this without pushing it into the variable, you can see that, you can see it's upset about, well, it's a little bit, looks like it's a little bit upset about the syntax here, but it actually produced our results. So you can see here that we have 7 users in our data frame that had more than 10 tweets, with this Frank Stone person being the overwhelming leader here, and then this Christina person has about 12 of those here. So we could actually get this same information from one of our other data frames where we had kind of summed this information up already and don't have to do these sort of grouping operations and whatnot. We've got a data frame that we created that basically already has this stuff aggregated together. So I'm going to run this sqldf command against that data frame, and here we can see that we're getting the same results back. And okay, maybe we want to get some tweets back. Let's look at Christina here. We've got our BTQ data frame, and we're just going to go ahead and issue a query against it where username is equal to Christina CJV here. So I'm going to run that, and you can see, oh, there's all the Twitter or all the tweets that are included in our data set. Now, if I want to persist these in an object inside of R here, I can actually just run the entirety of our commands here. You can see where we're pushing these into variables. So I'll run that, and now if, for instance, we wanted to see the contents of one of those variables, we could just execute it that way. And now we've got an object that contains the information that was in there. And this is kind of a common technique when you're doing this type of stuff. You'll kind of be parsing your data down into a data set that you can use, and often using, you know, perhaps a series of variables along the way as you process your data into a form that's useful for you. So here I'm just going to remove the password and connect string so I don't show those on the screen. And then if we pull up our environment, we should see all of the stuff that we need to create for our screenshot here. So you can see all the variables that include the results of our queries against our database, as well as the renamed iris data set that we created and pushed up to our database, and then the results from the sqldf operations that we did as well. And you can see here, if you take a look, the various queries variables that we used, driver class, driver path, and all the things that we use to produce to actually work through this exercise. So when you've completed it, you should be producing a screenshot that looks very much like this one, and that's what you'll attach to the assignment and turn in. As always, if you guys have any questions, please just reach out to me, and I'll get back to you as soon as is possible. I usually am able to respond to Skype a little bit quicker than email, so if you're in a big hurry, give that a try, and know that I will get back to you as soon as I can.